Unit 5 Pre-Assessment, Classifying Numbers, Roots, and Pythagorean Theorem, Part 1. Number 1, you're going to plot each of the numbers on the number line below. Be sure to label each point. So let's start with plotting -1/2 pi. Well, -1/2 pi is going to be -1/2 times 3.14. So half of pi, 3.14, is going to give you -1.57. So that's going to be somewhere between -1 and -2. So it's closer to -1.6. So I'm going to put a little further to the left than halfway between -1 and -2, closer to -2. And I'm going to label that -1/2 pi. Now the square root of 13. That one is approximately, well, that one's between the square root of 9 and the square root of 16. So that's going to be between 3 and 4. So when I put that in my calculator, that's going to give me approximately 3 6/10. So I'm going to plot that at 3 6/10 and label that the square root of 13. 3 and 51/100 repeating. Well, that's going to be halfway between 3 and 4, but closer to half. So I'm going to label that line 3 and 51/100 repeating. -3 and 5/10 is halfway between -3 and -4. And lastly, the square root of 9 equals 3, so I'm going to plot that exactly at 3. We'll label it as the square root of 9. So what numbers above are rational? So rational means that they are terminating decimals, they are perfect squares, they're repeating decimals, or they're whole numbers. So integers, positive or negative whole numbers. So if I take a look, anytime you have any number involving pi, that's irrational. So number 3 says what numbers above are irrational. Well, I can actually go in there and put in the answer of -1/2 pi. Again, pi means irrational. The square root of 13, that is not a perfect square, so that's going to be square root of 13, is irrational. For rational, that's 3 and 51/100 repeating, because that's a repeating decimal. -3 and 5/10, because that is a terminating decimal. And lastly, the square root of 9, because that is a perfect square. For 4a, we're going to explain why you placed square root of 13 on the number line where we did. Be specific and use complete sentences. Well, if I go up here, the square root of 13, we put it at 3.6. That is because it's between the square root of 9 and the square root of 16. That is closer to being the square root of 16 than it is to the square root of 9, which is 4. So explain why we placed it on the number line where we did. Be specific and use complete sentences. The square root of 13 is between the square root of 9 and the square root of 16. Square root of 9 equals 3, and the square root of 16 equals 4. So the square root of 13 is between 3 and 4. 13 is closer to 16 then 9. So 3 6/10 is the answer. I checked on a calculator. Oops, misspelled calculator. So approximate the square root of 17 to the nearest tenth. Explain in detail how you found your answer. Okay. So the square root of 16 and the square root of 25. Somewhere in between is the square root of 17. 16 and 25 are perfect squares, so we know that the square root of 17 is somewhere between 4 and 5. Now, it says to the nearest tenth in the directions. So that means what we're going to have to do is figure out, using a table, what are the numbers. Now, the number 17 is very, very close to 16. So I'm going to try that as 4 1/10. Then I'm going to try 4 2/10 and 4 3/10. So then so here's our x's, and we're going to do x squared. 4 1/10 squared is 16 81/100. Then 4 2/10 squared is 17, and 64/100. And then lastly, 4.3 squared is 18 and 49/100. So when we look at our three options, 16 and 81/100, 17 and 64/100, 18 and 49/100, you will see that 17 is closest to 16 and 81/100. This one right here. Because it's only 19/100 off versus 64/100. So to show you, if I take 17 and subtract 1681, I have to borrow, gotta borrow again. That gives me 19/100 versus 17 and 64/100 minus 17. That's a difference of 64/100. So, square root of 17 is approximately 4 1/10. You'll see that it says explain in detail how you found your answer, yet mine did not involve words. Mine involved mathematical showings. That is absolutely allowed. So we're going to convert the following fractions to decimals, and we're going to show work, and if needed, we're going to round irrational numbers to the nearest hundredth place. So we are going to take 4 and divide it by 9. 9 goes into 4 0 times. I got to add that decimal. Add that decimal up here. And have a 0 in with the 4. 9 goes into 40 4 times, so I'm going to subtract 36. 40 minus 36 is 4. I'm going to add a 0, bring it down. 40. 9 goes into 40 4 times. I'm going to subtract 36. That gives me 4. Now, you'll start to notice that there's a pattern with this one. 4 9ths is 4 10ths repeating. Okay, number 6, 1/4. Some of these you guys already know. This one you might know is 25/100. To show work, 1 divided by 4. 4 cannot go into 1, so I have my decimal place or decimal point in at the top of the bar. And then I'm going to add a 0 on the inside. 4 goes into 10 twice, so I'm going to subtract 8. I'm left with 2. I add a 0, bring it down. 4 goes into 25 times. So I'm going to subtract 20. That gives me 0. So therefore my answer is 25/100. But that's how I can show my work. All right, 3/7. We're going to do 3 divided by 7. 7 cannot go into 3, so I put a 0, add decimal, put a 0 after the 3. 7 goes into 30 4 times. So I'm going to subtract 28. 30 minus 28 is 2. Add a 0, bring it down. 7 goes into 20 twice. Subtract 14. That leaves me with a 6. Add a 0 and bring it down. 7 goes into 60 8 times. So I'm going to subtract 56. That leaves me with a 0. I'm sorry, it leaves me with a 4. So bring the 0 down. 7 goes into 40 5 times. Minus 35. Add a 5. Or that equals 5. Bring down the 0. 7 goes into 50 7 times. Minus 49 leaves me with a 1. So I don't see any type of pattern that's happening. And I also don't see that it's terminating. So therefore, this is a non-terminating, non-repeating decimal. So if the answer said to round to the hundredths place, then I want to round it to 2 decimals, which is 0 and 43 hundredths. I didn't know that it was irrational, that it was a non-repeating, non-terminating decimal until I kept dividing. So we're going to convert the following decimals to fractions in simplest form. We're going to show it using algebra. So number 8 is 4/10, just like how it's written. read. I'm going to write it as 4/10. Now I can't leave it like that because the denominator and numerator can be divided by 2. So you're left with 2/5. For number 9, 26/100 repeating. We're going to let that equal x. So x equals 26/100 repeating. Now we have 2 decimal places that are repeating, so I need to multiply that by 100. So that gives me 100x equals 26 and 26/100 repeating. And I'm going to subtract that from my original, x equals 26/100 repeating. You do want to match up the 26/100. That's repeating. 100x minus x is 99x. 26 and 26/100 repeating minus 26/100 repeating. These two are identical, so that actually simplifies to a 0. So you're just left with 26. From here, you want to divide both sides by 99. And you get x equals 26 divided by 99. Now we do want to see if we can reduce. 99 can be divided by 3, 9, and 11. 26 cannot be reduced by any of those. So your final answer is 26 divided by 99. Number 10, 125 thousandths. 125 thousandths. So that means it's 125 divided by 1,000. Now I can divide the numerator and denominator by 25. That's one of the larger numbers that I know can go into 125 and 25. So 125 divided by 25 is 5. And 1,000 divided by 25 is 40. Now 5/40ths can still be reduced. I'm going to divide the numerator and denominator by 5. That leaves me with 1/8. If I double check 1 divided by 8 on my calculator, that gives me 0 and 125 thousandths. So I'm going to place the numbers in all the areas that they fit. If needed, we can look them up in the book or in our notes. So real numbers are every type of number that we have learned this year. Irrational numbers are non-repeating, non-terminating decimals, or anything involving pi. They are also non-perfect squares. So I'm going to look at my options below and see. And number 11 is negative pi. Well, I'm going to immediately put that into my irrational because it's involving pi. I'm going to look and see if I have any other options with pi. Number 16 also has pi. Negative 4 pi divided by pi. Well, actually, I had to go back. I had to erase that. So let me go back to number 12. Square root of 13. That is a non-perfect square, so that goes into irrational. Number 13, 5 and 34/100ths repeating. Well, it's a repeating decimal, so that makes it rational. It is not an integer because it's not a positive, negative whole number, and therefore it's not a whole number. That's not an option. So this is located with the irrational numbers. Number 14, negative 6 and 7/10. That is also rational. It's a terminating decimal, but it is not a positive or negative whole number, so integers is out, and also is whole numbers. Square root of 16 is 4. So 4 is not only a rational number, not only an integer, not only a whole number, but it's also natural. So the square root of 16 is natural. It's every single one of the options, but I'm just putting in the most specific category and rewriting natural. Negative 4 pi divided by pi actually simplifies by taking those pi's out, and you're left with negative 4. Negative 4 goes up to being an integer. So negative 4 pi divided by pi. And that is because the pi's simplify out to 1. All right. Is 66/100 the same as 2/3? Explain your reasoning. Well, some of you know that 2/3 is 6/10 repeating as a decimal. 66/100 is a non-repeating number. It terminates. So therefore, they are not going to be the same. But just to show, if I have 2 divided by 3, 3 cannot go into 2, so I'm going to put a 0 at the top. put up a decimal and fill in a 0. 3 goes into 26 times. So minus 18. There's a 2, add a 0, bring it down. 3 goes into 20 6 times. Minus 18 gives me a 2, 0, bring down that 0. 3 goes into 20 6 times. Subtract 18, that gives me 2. You'll see that there's a pattern. It just keeps repeating. So 6/10 repeating equals 2/3. 66/100 does not equal 6/10 repeating, because 6/10 just keeps repeating indefinitely, while 66/100 terminates after 2 6s. Okay. So here the teacher handed Dominic and Eloise a calculator that showed the following display, which entirely filled the calculator screen. Then the teacher asked whether they thought the number displayed was rational or irrational. Dominic thought it was rational because it had used every possible digit, 1 through 9, and was bound to repeat itself. Eloise thought it was irrational because it didn't have a recognizable pattern yet. What do you think and why? So if we take this screen, 0.296457318. There is no recognizable pattern that is happening. No numbers are repeating. We don't know if it's terminating because this is filling the entire calculator screen. So this could have kept going. So this number is going to be irrational. Non-repeating non-terminating decimal. So let's move on to number 19. True or false? Square root of 32 is less than 27 divided by 4. Explain in detail how you know. So the square root of 32, that is between the square root of 25 and the square root of 49. Oh, I meant to say square root of 36. I apologize. So I know it's going to be somewhere between 5 and 6. Now if I take the square root of 32 and I break it down, it's going to be the square root of 4 times the square root of 9. No, I'm sorry. Not the square root of 4 and the square root of 9. Square root of 4 and the square root of 8. And that's going to be 2 root 8. Now I notice that 8 can be broken down into the square root of 4 times the square root of 12. So that's going to be 2 times 2 root 2. So that's 4 root 2. And for 27/4, that becomes 6 3/4. So 4 times the square root of 2 is going to give me 5 66/100. Well, 6 3/4 is 6 75/100. So that means that the square root of 32 is less than 27 fourths. Because the square root of 32 is approximately 5.66. 27 fourths equals 6 75 hundredths. So therefore, 5 66 hundredths is less than 6 75 hundredths. We're going to simplify the following expression using perfect squares and cube roots. Actually, you guys can cross number 21 out. We're just going to do number 20 on this line. So negative square root of 49 is negative 7. Now, number 22, we have 2 square root of 144 minus 6 square root 4. The square root of 144 is 12, so this becomes 2 times 12. You'll notice that I don't have it as the square root of 12, and that's because I already found out the square root of 144. We're going to subtract this by 6 times 2. So 2 times 12 is 24, minus 6 times 2, which is 12. 24 minus 12 equals 12. You're also going to cross out number 23. We did not do cube roots or anything involving cubes. We're going to use the number line to identify the amounts listed below, then circle if the number is rational or irrational. So the square root of 22. Well, if I look at that, that's going to be somewhere between the square root of 16 and the square root of 25. So somewhere between 4 and 5. Is larger than 4 but less than 5. This is irrational because it is not a perfect square. And 2 pi is going to be 2 times 3.14. Again, we're just rounding, which is 6 28 hundredths. This is irrational because it is involving the number pi. So 2 25 hundredths is rational, and that is because it is a terminating decimal. Square root of 81 is 9. 9 is rational. 24 fifths, well, 5 can go into 24 4 times. So 24 minus 20 is 4. That is 4 4 fifths. Or 4 8 tenths. This is rational because it can be written as a fraction or a terminating decimal. 12 42 hundredths repeating. This is going to be rational because it is a repeating decimal. Repeating decimals are rational. Now, we have to go back and figure out what the points are. So I need to find my smallest point. My smallest point is 2 25 hundredths, so that's going to be the letter D. So number 26, the point is D. Next smallest number is going to be, I believe, the square root of 22. So the square root of 22 is approximately 4 7 tenths. So that's going to be at point A. 28 is 4 and 8/10, so that's going to be at C, very close to letter A. So that makes sense. Then letter B is going to be 25, because next comes 6 and 28 hundredths. Number 27 is going to be E at 9, and letter F is going to be 29.